welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be looking at alkynes. So we are going to see the nomenclature of alkynes and also the members of this group and how they are usually presented. So first of all, alkynes are a general formula of a CnH2n 2 and a triple bond as the functional group. The n number of carbon atoms is the number of carbon atoms in the molecule. So remember we said for alkenes, we do not start with n is equals to 1, it starts from n is equals to 2. So this also applies with alkynes where it starts from 2 carbons and so forth. So when you go back a little bit, we said that alkanes as a formula of CN H2n plus 2, and then we add alkenes with a CN H2n. So you can see where we are heading to. For alkynes, it's going to be CN 2n minus 2. So for the carbon atoms, I usually linked at least to one triple bond to each other, and then single bonds to the hydrogen atoms, which is a bit similar or different from what we discussed with alkenes, because for alkenes we had a double bond between two carbon atoms, and in this case we're going to have triple bond. So the triple bond in alkyne is the functional group, and it is the reacting site of alkynes. So the triple bond is easily broken to accommodate like 4 more monovalent atoms. This makes alkynes to be very reactive in comparison to alkenes and alkynes. So the triple bond in alkynes makes it also unsaturated, just like in alkenes, and most reactions occur at the triple bond. So when now we look at the structure of this and the names of these group members, their name usually have a suffix of "-ine" after the prefix. The prefix starts from eth, prop, but, pent, et, and so on and so forth. So you can start with the first 9 members. The first member is eth, then "-ine", and then the second one is going to be prop, then "-ine", propine, and then the third is going to be butane. The fourth is going to be pentyne. The fifth is going to be hexyne. The sixth is going to be heptyne. The seventh is going to be octyne. And the eighth is going to be nonine. And finally, decyne. So you'll notice, just like we said in alkenes, that when you asked for the first member, you normally would think the first member has to do with the first carbon. But in this case, the first member starts from ethyne as well. So you need to start it from ethyne, which is contrary to the first member in alkenes. So the second way is representing it in the molecular formula. So when you look at the molecular formula, we get the different types of atoms and the number of each. So when you look at the first member, which is ethyne, it has 2 carbons, and we said there's a triple bond bonding the 2 carbons. We said a carbon can have a maximum of 4 bonds, so it is important that you count these bonds. So for this carbon, you can see the first 3 bonds. So this carbon requires one bond, and this other carbon requires 1. So this is so different from the way we were writing on alkenes. So it's very important you count the number of bonds bonding the carbon atom. So the next member is going to be propine with 3 carbons. So we show the 3 carbons, and then in the first carbon we put the 3 bonds. So this is hydrogen. So you notice the center carbon is fully bonded because you can see there are 3 bonds and 1 bond. So this is fully bonded. We are not going to add any more bonds, but the final one requires 3 to be able to be full. So we introduce the hydrogens. If we look at the third member, which is butane, this has 4 carbons, so we draw those 4 carbons. So we put the triple bond in the first 2 carbons. So this carbon has 3 bonds, so we require 1 bond, so we introduce the hydrogen. This center one is fully bonded, as you can see, it has 1, 2, 3, 4, so we do not add any more. For this other carbon, it requires 2, so we add those 2, and then this other carbon requires 3. And we go to the fourth member. The fourth member is pentane. It has 5 carbons. So the first 2 carbons will accommodate the triple bond. So this carbon here at the end requires 1 more bond. So we put the hydrogen. And then this center one is completely full. So we do not need to add. As you can see, this is surrounded by 4 bonds. But this one requires 2 bonds. So we put those 2 bonds. This one requires 2 as well. This one requires 3. And then finally, we have, after pentane, we have the hexane, which has 6 carbons. So you notice the structure that we are drawing here is a structural formula. That was an error. We're supposed to be working on the molecular formula. So we are going to work on the molecular formula in a minute. So we are going to cancel this out to be, this is going to be, instead of molecular formula, it's going to be structural. So you'll get an opportunity in the next step to look at the molecular formula. So let's finish up on the hexane. So we'll put the triple bond in the last carbon. So this carbon will require 1. This one is completely full, but this one, it requires 2 more. And this one also requires 2 more. This as well. And this as well. So this structural formula can also be condensed. If we condense it, the first one is going to be CH, as you notice. The second one is CH, then CH3. You can see there is no hydrogen in the inner one. The butane is going to be CH, then CH2, and CH3. And then pentane is going to be CH, and then and then CH2, CH2, and CH3. And then hexane is going to be CH, then a C, then CH2, 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 and CH3. So what we are shown is the condense. Remember, you can condense it further. For example, in pentane, you can do CHC, and then the CH2, you put it in the bracket, and there are 2 of them to show these 2, and then CH3. So this is the structural formula. So let's look at the molecular formula that we were supposed to look at before this one. So when we look at the molecular formula of ethine, we start with ethine. We have, remember the general formula is CnH2n minus 2. So this is going to be C2. So 2 times 2 is 4, 4 minus 2 is 2. So it's going to be H2. And then we look at the second, which is propane, which is C3. So it is 3 times 2, which is 6. 6 minus 2 is 4. So it becomes H4. And then we go to butane, which is C4. 4 times 2 is 8. 8 minus 2 is 6. So H6. And then we go to pentane, which is C5. So 5 times 2, 10. 10 minus 2 is 8. And then we go to hexane. So C6H. So 6 times 2, 12. 12 minus 2, 10. And then heptane, which is C7. 7 times 2, 14, 14 minus 2, 12. And then octane, so CH, 8 times 2, 16, 16 minus 2, 14. And then we have no 9, C9, 9 times 2, 18, 18 minus 2, 16. And finally, decyne, which is C10, 10 times 2, 20, 20 minus 2, 18. So that's the molecular formula. Finally, we look at the zigzag or the skeletal notation. So for the ethyne, so you write one zigzag line. At the end, we know there are two carbons, but in this case, you put a small line on top and another small line at the top. So rarely will you see for ethyne, but starting from propane, so this one has 3, so you can see one carbon here, another one, and another one. So you put a small line below and another small line above. So we go to butane. So we have first carbon number 2, number 3, number 4. So you put a small line here and a small line here. And then we go to pentane. So 1, 2, 3, 4, 5. So one small line here and one small line here. And then hexane, which is going to be 1, 2, 3, 4, 5, 6. Put a small line here and a small line here. And then we go to heptane. So 1, 2, 3, 4, 5, 6, 7. So a small line here and a small line here. And then octane, 1, 2, 3, 4, 5, 6, 7, 8. So a small line here and a small line here. And then nonine, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Small line here and a small line here. And finally, decyne. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So a small line here and a small line here. So that brings us to the end of nomenclature in alkynes. So see you in the next lesson as we look at how we name alkynes.